Okay, let's look at 5.4. This is called polynomial division, and this is going to help us factor polynomials that we don't currently have tools for. The particular kind of polynomial division that we are going to do is synthetic division. Now, you might also be familiar with polynomial long division. We're not going to do that. So the setup is if we have a polynomial function and we're given a 0, in this case x equals to -2. And we want to find the other real zeros of that polynomial function, and we want to write that function in its fully factored form. Okay, let's write down what we know if x equal to -2 is a 0 of this function. That means that f of -2 equals 0, and it also means that x plus 2 is a factor of that polynomial function, okay, because x equal to -2 would come from that factor, x plus 2. Now, if x plus 2 is a factor, that means that we could write f of x equal to that factor of x plus 2 times some other factor. We don't know what it is. But that other factor is going to give us the other zeros, which is what we want. One of the things we want, right? The other real zeros. So how do we find the other factor? Well, let's think about this algebraically. If we wanted to solve for that other factor, what would we do? Right now it's multiplied by that x plus 2. So to get other factors by itself, we divide by x plus 2. And if we do that to that side, we do it on the left side. All right, so the x plus 2's would cancel, and we would have the other factor equal to the function over x plus 2. All right, well, we know what that function is, so we can write that the other factor is equal to x cubed minus 6x squared minus x plus 30 all over x plus 2. All right, so you can see how being able to do division is going to help us find that other factor. Okay, let's learn how to do synthetic division. We want to divide our polynomial by our factor x plus 2, and that's going to give us our other factor. So we're going to go step by step here. First thing is we set up this half rectangle, and this is just a setup step. That's what we mean by a half rectangle. Now the second step is to write k for the divisor. So our k, that is going to come from here, and k is the 0. Okay, so it's so the 0 is x equal to -2. All right, so that goes in this position right here. Okay, next step is to write the coefficients of the polynomial functions. So the polynomial function is what we're dividing, so the coefficients of this polynomial right here. So we have a coefficient of 1 on the x cubed, and then a -6, and then a -1 on the x, and 30 for the constant. Okay. All right, next step is to bring down the lead coefficient. So we bring that 1 down. So I'm just going to, we don't have to write that arrow, but I'm just saying that's what that means. It brings that down. Okay, next step is to multiply the lead coefficient by k and write the product in the next column. Okay, so we're going to multiply 1 times negative 2, and that product goes in the next column under the next coefficient. Okay, and then the next step is to add down that column. So negative 6 plus negative 2, right, that's going to give us a negative 8. All right, next step is to multiply the result by k and write it in the next column. So negative 8 times negative 2, we get a positive 16. Okay. And now we are going to continue to repeat those steps. So steps 6 and 7. So 6 says add down that column. So negative 1 plus 16, that's going to give us 15. And then we take that 15 multiplied by negative 2, and we get a negative 30. We repeat the adding down. 30 minus 30, we get a 0. This last number that we get after the last addition, this is the remainder. When we do division, a lot of times we will, if it doesn't go in evenly, we get a remainder. Well, here we have a remainder of 0. Okay, if the remainder is 0, okay, if the remainder is 0, then what we divided by is a factor. And so we did get a remainder of 0, so that means that x plus 2 is a factor. Okay, I wasn't making that up. But the other piece that we learn is that the numbers to the right of that remainder are the coefficients of the other factor. Okay, so that tells us that these numbers are the coefficients of the other factor that we were looking for. And the other factor has 1 less degree than the original function. Okay, so our original function had degree of 3. So our other factor is going to be degree 2. That means the largest exponent is 2. All right, so we take those coefficients. All right, we have that coefficient of 1. Okay, that's going to go on x squared term. And then we've got a coefficient of negative 8. That goes on the x term. And then we've got coefficient of 15. That's the constant. Okay, so this is the other factor. Now we can write our function. We can write our function in factored form. We have f of x equals, well, we knew that x plus 2 is a factor, and now we have our other factor, x squared minus 8x plus 15. All right, and remember, we also want to find the real zeros. So we're going to set this equal to 0 to find the other zeros. So x squared minus 8x plus 15 equals 0. I think this is going to factor for us, so we're going to have an x and an x, and we want the two numbers that add to positive 15 and we want the two numbers that multiply to 15 and add to negative 8. So I think that's going to be negative 3 and negative 5. So if we set those equal to 0, we get our other real zeros. We get x equals 3, x equals 5. Okay, so that answers the first part of the question. And so that was x equals 3, x equals 5 goes along with x equals 2, or x equals negative 2 as the real zeros of the function. The second part was to write it in factored form. So factored form is just the polynomial written with its factors. So our original polynomial, we had x cubed minus 6x squared minus x plus 30. Well, now we can write that as x plus 2, and then x minus 3. All right, I'm just getting that from up here, and then x minus 5. Okay, we're going to do some more examples of synthetic division and determining if a given factor is a actual factor of a polynomial function. So we have a couple of theorems that I've summarized for us, and it says if a function f of x is divided by a factor x minus k, then that remainder is f of k. Okay, so whatever that is, it's evaluated at that value k, if that zero, or if that factor is x minus k. Now, if the remainder is 0, then that means that k is a 0 of f of x. All right, so we're going to apply that to the following exercises. We're going to use synthetic division to determine if the given factor is an actual factor of the polynomial. Okay, so the number 38 there, that's the number in the textbook, the exercise number in the textbook for this section. Okay, so we do the setup for the synthetic division. There's our little half rectangle, and the 0 that comes from x minus 2, right? If we were to set that equal to 0, we would get x equal to 2. So 2 is what goes right here. And then we list out the coefficients from the polynomial. So it's 4, negative 3, negative 8, and 4. Going through the steps in synthetic division, we bring down the 4, multiply that 4 times 2, and we get 8. Put that under the negative 3, add down and get 5. Multiply the 5 by 2, and we get 10. It goes under the negative 8. We add down and get 2. And multiply that 2 by this 2. And we get 4. We add down, and that gives us an 8. Okay, so this is the remainder. And I'm just going to use a capital R to stand for remainder. It's not equal to 0, but what that tells us is if we evaluated the function at 2, the result would be 8. And since it is not equal to 0, that means that x minus 2 is not a factor. Okay, so x minus 2 is not a factor, and 2 is not a 0 of this function. Okay, another example. So we want to see if x minus 2 is a factor of this polynomial that's given. So x minus 2 is the factor, and the 0 that goes along with that is a positive 2. So that goes right here. Then we want to put in the coefficients of the polynomial. Okay, we have a 4th degree polynomial. First coefficient is 3, and then negative 6. Now notice there's no x squared term. So there's no x squared term. Well, when we write down the coefficients, we don't want to skip over any of the descending degrees. So because there's no x squared term, we're going to put in a placeholder of 0 for that x squared term. and then continue on with the -5 and the 10. Okay, let's go through the steps in the synthetic division. So bring down that 3, multiply the 3 by the 2 and get 6. Add down, -6 plus 6, we get 0. Multiply 0 times 2, we get 0. Add down, 0 plus 0, we get 0. And now we multiply 0 times 2, we get 0. Add down, we get -5. And -5 times 2, we get a -10. And then add down, this time we do get 0. So that is the remainder. Use uppercase R to stand for the remainder. So that means that f of 2 equals 0. And that's the definition of a 0. So that tells us that x equal to 2, this is a 0. And x minus 2 is a factor of this polynomial. Okay, so we answered the question. It is a factor. Okay, we want to do the same thing. We want to see if that factor x minus 2 is an actual factor of that polynomial that's given there. So start off with the setup of half rectangle. And from that x minus 2, that gives us a value that we're dividing by of 2. Now we put in the coefficients from the polynomial. And so we've got a 4. Notice that there's no x cubed term, so we want to put a 0 in for that. And then we've got a -15. There's no x term, so we put in a 0 for that, and then -4. Now let's go through the synthetic division. All right, we bring down this 4. We multiply that 4 times the 2, and we get 8. Add down, and that gives us an 8. That 8 times the 2 is 16. Adding down, we get a +1. 1 times 2. Add down, we get 2. And then 2 times 2, we get a +4. We add down, and that gives us a 0. And our remainder is 0. So that tells us that f of 2 equals 0. So 2 is a 0 of the function, and x minus 2 is a factor. Okay, this isn't a part of the problem, but we can write this in partially factored form. Just kind of want to remind us of what these other numbers tell us, right? Those are the coefficients of the other factor. So the coefficients, I'm going to abbreviate that, of the other factor. So if we write down this polynomial in partially factored form, well, we know x minus 2 is a factor, and then we have the other factor is going to be 1 less degree than our original, so it's going to be cubed. It's going to be degree 3. So we get 4x cubed plus 8x squared plus x plus 2. One more example. This is like number 3 in the assignment for 5.4. And we want to use the graph of a third degree polynomial, so it has an x cubed term, and one factor to write the factored form of the polynomial suggested by the graph. Okay, so basically what this is saying is we want to come up with the function f of x equal to some factor that we don't know all right, times that factor that's given, which is x squared plus 2x plus 4. All right, so we want to figure out that sum factor. Okay, well, we are going to get that from the graph, and right here we have an x-intercept. So we have an x-intercept at x equal to 1. So that means that 1, x equal to 1, is a 0. And that means the factor that it comes from is a factor of the function. And so x minus 1 is the factor that comes from the 0 of 1. Okay, so that sum factor that we're looking for is x minus 1. So we can write down our function f of x equals x minus 1 times that factor that was given, x squared plus 2x plus 4. And we don't need to multiply it out. We can just leave it like that, and that's our answer.